Welcome back. Today we'll cover inverse functions. So inverse functions are shown with f raised to the negative 1 of x. So for any function f of x, we use the notation f to the negative 1 of x to represent inverse functions. Now let's look at inverse functions. So we have two functions here, f of x and its inverse. F of x is 2x. So if I completed the table, it would just be negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8. And if I use the, the inverse function right here, and I plugged in x, we would get negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. So you can see, comparing the table, that the x value over here becomes the y value for the inverse. And then the y value for f of x is the x value for the inverse. So let me graph both of them. And they're just going to be lines. So the first line just has a slope of 2. Okay, this is not a perfect sketch here. This should have been down here. Okay, and then for the next line, it's just 1/2 x, right? So that'll just have a slope of 1/2. So let's consider a couple of things when we look at the inverse. So the inverse and the range, that relationship, just like we showed with the table, the domain of the function, I'll write this a little bit bigger, is going to be the range of the inverse. And vice versa. So the range of the domain, the range of the function is also the domain of the inverse. Now, the line of reflection, y equals x, you could notice here, I'm just going to sketch this line. But you could see that every point here on this blue line, I'll use the light blue from here, if this is 2, 4, the coordinate 4, 2 is on the inverse function. So if we put that together, we know that for every point on the function, its inverse will be the reflection on the line y equals x. So the line y equals x is the line of reflection for f of x and its inverse. All right, so let's consider a couple other things. So to have an inverse function, we need to make sure that the function that's given, f of x, is 1-to-1. So we know that a function, remember, I'm just going to write the definition for a function. Every x has one y. Now, for a 1-to-1 function, we're saying every y also has only one x. Okay, so when we tested for a function, remember we had the vertical line test? And we would check if every x had one y. Well, we could use the horizontal line test to check if a function is 1-to-1. So just looking at this function up here, we can actually see that when we draw these lines, and I'll use a different color here, when we draw horizontal lines, it only touches the function once. So that means every x has only one y, and every y only has one x. Now let's go to the definition. The definition, again, we're talking about the domain and range. Okay, so that's highlighted here, that the domain of f must be the range of its inverse, and the range, there's two m's by accident, sorry about that, the range of the inverse, or the function, must be the domain of the inverse. Okay, now let's look at the composition. So the definition of inverse functions is that essentially if you essentially plug one function into the other, make a composition, everything should cancel. All the values should negate each other, and you should come up with the function y equals x. And notice y equals x is the line of reflection. So when you plug a function into its inverse, everything should cancel, just like inverse operations, and then you'd be left with y equals x. So if we were going to verify that functions were inverses, we would have to plug them into each other. So f of g of x, I'll put that over here, and then I'll have g of f of x. So for the first one, we're going to plug, I put g, I should just put the inverse. And then the inverse of f of x. Okay, so here I'm going to plug in the inverse into this function. So we get 8 times x over 8, and essentially we get x, that y equals x. And then for the next one, we're going to plug in f of x into its inverse. So it's going to be 8x over 8, which equals x. So those two functions are indeed inverses. Now let's look at b. So I'm going to plug in the inverse into the original, and then I'll plug the original into the inverse. So here's going to be the inverse into here, so that's going to be 2 times x plus 3 over 2 minus 3. That'll be x plus 3 minus 3, which equals x. And then for the next one, we're going to plug this into the inverse. That's 2x minus 3 plus 3 over 2, 2x over 2, so that equals x. Now let's go to part C. So we're going to plug again the inverse into the original, and the original into the inverse. So here's the inverse. So square root of x minus 6 squared plus 6. So that's just going to be x. And then when we plug in the original into the inverse, it's going to be x squared plus 6 minus 6, which is the square root of x squared, which is x. Okay, and you may notice right here, this was really plus or minus x, right? So we're going to look at that graph because you do have to be careful with parabolas. So the function, the original function was x squared plus 6. And we just showed by definition, and this is just a general sketch, okay? We just showed that those were indeed compositions because when you plugged one into the other, everything canceled and you had x. But when we look at this parabola, hopefully you can see right away that this function is not one-to-one. So yes, it has an inverse function, but this function itself cannot have an inverse unless we restrict that domain. So I'm going to sketch this next function here, the inverse, and that was x minus 6, or the square root of x minus 6, so it's like this. Okay, so just imagine here's the line of reflection. And you could notice that it's really this right part, the increasing interval, that is the function. So I actually want to make sure I restrict the domain for this parabola. We're just looking for the parabola's inverse from 0 to infinity. So we want to make sure we restrict this domain. F of x was x squared plus 6, and we're only using the values greater than 0. So I could just write from 0 to infinity. So that's the domain restriction, okay? Because if we looked at that left half, it actually wouldn't even be represented with the square root. So just be careful with parabolas because you actually do have to restrict the domain to have an inverse. So how do we find the inverse function? So if you do have a function that passes the horizontal line test, you can write the equation for the function. And it's easy steps. You simply replace the f of x with y. We're going to interchange the roles of x and y because the inverse function, remember, the input becomes the output becomes the input for the inverse functions, and then we'll rewrite it with the inverse function. Step 5, you can verify them as well, and we just showed how to verify them, but for these examples, I'm not going to verify them. So here we have f of x. I'm going to replace that with y. The second step was to replace or interchange y and x. So to get the square root by itself, or to remove it, we're going to square that. So x squared equals y plus 6. And then we could rewrite that as y equals x squared plus 6. And we want to make sure we show that this is the inverse. So this is, I'm just going to make sure I write that as f to the negative 1 to show it's the inverse. Now for b. Same thing, we're going to interchange this with y and interchange, so we have x equals y plus 2 over y minus 5. Now I'm going to have to do a little algebra here so that I can get the y's to one side. So xy minus y equals 5x plus 2. Factor out a y, so that's x minus 1. And then I'll write on this side over here. So y equals 5x plus 2 over x minus 1, or I could write that as the inverse. So that one's a little tricky because you do have to simplify it, essentially distribute this x. So we get xy minus 5x. Get all the y's to one side and then factor out a y and then divide by x minus 1. This one's not so bad. We're going to again rewrite that with a y and then interchange x and y. So 2y equals x plus 7. So y equals, and I'll just write it in slope-intercept form, 1/2 x plus 7 over 2. And remember, we're going to replace that y with f to the negative 1. And just remember, if it said g of x, we put g to the negative 1. All right, this one's very similar to the last one. So again, we're replacing this with y and then interchanging the variables x and y. So we multiply by y minus 5 again. So xy minus 5x equals 2x plus 3. Factor out. We're going to actually, let's combine these first. So put the 2y over here, so minus 2y. Add the 5x. Factor out the y. So this is x minus 2. And then we have y, or I'll just put the inverse, will be 5x plus 3 over x minus 2.